And last but certainly not least is 25, where it says, after a reflection over a line, your image, triangle ABC prime, is the image of triangle ABC. You're saying, explain why those triangles are congruent, why the pre-image, triangle ABC, is going to be congruent to its image. So what you need to know is the transformations that we've studied in Chapter 1, a reflection, which is a flip, a rotation, which is like a turn or a spin, and a translation, which is a slide. Those are what we call rigid motions or rigid transformations, okay? And what that means is when you do that transformation, you're going to have what's called an isometry. The transformation preserves length and angle measure, preserves size, right? Because size is determined by length, and it's going to preserve shape, which is angle measure. So if I've got a triangle that looks like this, A, B, C, and then I reflect over this line here, my image, yeah, it's going to be flipped, but this new side, C prime, A prime, it's going to be the same length as the original AC. And this B over here is going to be the same length. And same thing with C prime, B prime. Now, I messed up the drawing a little bit, but when you do a reflection, all you're doing is flipping. You're not stretching it out, you're not shrinking it, you're not crumbling it up and making a new shape. You're just flipping it, all right? You're doing a transformation that preserves length and angle measure. So there's two responses, I would say. You could say triangle ABC is congruent to triangle A prime, B prime, C prime, because a reflection simply flips the shape, comma, it preserves shape and size. Or you could say, instead of it preserves, shape and size won't change. That's one method. The other method is this vocabulary word. If you're in the know, you could just say, look, triangle ABC is congruent to triangle A prime, B prime, C prime, because a reflection is an isometry. And now that I've just said that, I'm almost going to say I wouldn't do that response. I think this one is the best. You're going to say what the transformation is and that it preserves shape and size, which is the definitions of congruence. Because when we were grading these Regents exams, I think they unfairly dinged students a point for saying isometry. It's like, because you're high order, because you know this mathematical term, you didn't spell it out for the Regents graders. You didn't tell them, hey, reflections preserve shape and size. They're really fishing for that. You need to say that type of transformation keeps shape and size the same from original to image. So that first one is kind of what we're looking for here.